When it comes to JSON and parsing, what we're really trying to do is bridge two worlds. One where the format of the incoming message is text, or JSON, and the other where the abstractions are represented as structs in Swift. The bridge between these two worlds is the Swift Codable, and it works like this. Say we have some incoming JSON coming in representing a modem. We can convert this JSON into a Swift struct by defining a struct, making it implement the Codable protocol, and matching the struct's property types with those of the incoming JSON model. All we need to do then is take that JSON string, convert it into data, and then use the JSON decoder to decode that JSON using this type and this data, and voila, we will get back an actual Swift construct populated with the data from the JSON model. That's it. And going the other way, we can also go from Swift to JSON by defining a struct with the properties we like to represent as JSON, this time using a JSON encoder, encoding that into a string, and then finally getting our string representation as JSON based on the Swift property types. Now you might be wondering, well, what if the Swift property types don't exactly match the JSON coming in? Swift Codable's got you there too. Say we want to represent first name, last name as camel case strings like this, but it's coming in the JSON with some underscores. That's where we can use these things called coding keys. They basically bridge how we'd like to represent the data in Swift with how it's coming in JSON. So if our JSON data comes in looking like this, we can still use the same construct for our structs on that data and still get it populated just the way we like. Other encodable JSON types include everything from URLs, numbers, booleans, arrays, dictionaries, nulls, you name it, it's there. Take a look at this arbitrary piece of JSON. It's got a little bit of everything. It's got strings, ints, optional booleans, arrays, dictionaries. We can parse this too. By creating a struct representing all of these properties, we can also take those and even handle embedded structs within the JSON. Take a look at platform. Platform is another type we can create within the JSON. It's nested within the outer JSON. All we need to do in Swift is create an equivalent struct, give it the same property names, and Swift will automatically decode and match that incoming structure. So when we run that, we can also decode it and get back some really sophisticated JSON parsing, all using the Swift Codable. Now this looks really easy, and it is once you understand what's going on. But we got to get you some practice working with JSON Codable. So we're going to switch gears now, jump into the arcade, and get you encoding some of your own JSON. All right, we'll see you in there. Okay, so to get going in this arcade, go into our repo, open up the Weathery app, and in there you should see a playground section, and double click on the JSON Arcade Playground. And that'll open up a Swift playground where we can actually work through and encode and decode some real life JSON. And it's a good thing you're here because the rebels really need your help. The first challenge for you is to find the imperial base. We've just got this incoming JSON coming in from some of our rebel friends, and we need you to decode it. We need you to create a Swift struct called coordinate capable of decoding this incoming JSON message. Now to help you do that, go ahead and open up the sandbox we just went through, this one here called JSON Playground. In here, you'll see the example of the US robotics modem we went through. You'll see how we took this JSON, created a struct, matched the properties, and then you use these two lines of code here to actually decode it. See if you can do the same thing for the incoming rebel message. Create a coordinate struct, see if you can decode this incoming JSON, and then we'll get together after and take a look at the result. Okay, good luck. Okay, how did that go? Were you able to decode the incoming message? Let's start by creating our Swift struct called coordinate. So we've got a coordinate structure. Now, of course, to parse JSON, we need to implement that Codable protocol. So there we go. This is how we're going to parse the JSON. Now we just need to match these to the property types in our struct. So let's create one called exactly the same thing we see here. Let's create one called latitude, and let's define that as a double. And then let's create another one called longitude and define that also as a double. Now we just need to use this to translate that incoming JSON data. So let's start by just taking the string, this JSON string, and converting it into data, which we can do with this line here. So we're going to take our JSON string, JSON1, convert it into data using the UTF-8 encoding. That's going to convert that into a string. Once we've got that string now, we can use our JSON decoder, pass it in the struct that we just created along with the data, and see if this gives us a populated struct of coordinate type Swift ready to go. And let's just see if we can do that by printing out the result latitude and the result longitude. If we can do that, we know we found the base. I'm going to go Shift Command Enter to run this. And if we check the output, hey, excellent, there we go. 44, 55, we're able to decode the coordinates. Okay, good stuff. Let's move on to the next one. Okay, in this next challenge, we're going to build upon the one we just did. We're going to associate those coordinates with a planet. So here's the JSON that we need to decode. It's got a name, a founding year, a couple of strings. But look at this. It's also got this thing called location, which happens to have the same attributes we just parsed up here with our coordinate. This one gets a bit trickier, but see if you can write a struct called planet that can decode these properties along with the coordinate from our previous example. Okay, good luck.
Rick 5, I'm going in.
Okay, how did this one go? Were you able to work it out? Don't worry if you weren't. This is tricky stuff at first. Let's do it together. Let's start by creating a struct called planet, since that's what we want to decode. And of course, we're going to do our decodable protocol thing. Okay. Now, what do we have here? We've got a name property, and it looks like it's a string. So let's go name string. That'll handle the first attribute. What do we got after that? Looks like there's something called founding year. Founding year, and that looks like it's an int. So why don't we just start with that? Now after that, this gets interesting. There's something here called location, but we don't have a Swift location object, but we do have something from the previous example called a coordinate. Now in this case, coordinate doesn't have to exactly match this word location here. We can define a type called location. That has to match, but we can make it of type coordinate. Do you see that there? Location here has to match, but the type describing it, that can be the Swift type that we've used previously to decode it. So let's type that there, and then let's see if we can decode the result. If we want to decode this, let's do the same thing we did before. Let's take our JSON string JSON2, convert that into data, pass that data along with the struct that's codable that we want to use to decode it. And if we run that by going Shift Command Enter, and we check the output, hey, we've got a planet populated with the name Tatooine, a founding year as an int, and a location which also has our 44 and our 55 coordinates decoded in there. Great stuff, everyone. Great work. Okay, for our final challenge, there's been a disturbance in the forest, and someone has actually changed and altered the very fabric of the planet itself and changed the names from being name and founding year to this lowercase style of planet name and founding underscore year. That's what we need to parse now. I'll give you a hint. We're going to have to do something with these codable keys. We're going to have to figure out how to translate these underscores into something nice like name and founding year that matches our previous description. Take a run at that, see if you can do the translation, come back and we'll do it together. Okay, good luck. All right, how did that go? Were you able to translate and handle those underscores? We can do that, remember, using those special code keys. That's basically what's going to handle and map the property we want name to an incoming JSON property of a slightly different spelling, planet underscore name. So to solve this, I've just created a new structure here called other planet, so it doesn't conflict with the name of our previous planet, and it's got the same codable interface. And we can keep the same definitions for name and founding year, even though they don't match here. That's okay. That was kind of the goal here. We've still got a location, that's a coordinate, but look at how we handle this. Coding keys, string, coding key. This is an enum where we're basically saying name here can be mapped to planet underscore name here. Likewise, founding year can be mapped to this JSON incoming style of founding underscore year. That's how we can translate these JSON properties into these Swift properties here. Even though we don't do a translation on location, we need to include it here for completeness. If we don't do this, we will get some kind of compilation error saying that we don't fully conform to the protocol. That's why that very last location is there. But if we run that and take a look at the result, we'll find out that we can indeed decode it and get back our fully other planet populated with all the properties translated from here. Good stuff, everyone. So hopefully that gives you a better feel for how the JSON parsing and decoding work. Let me now show you how we're going to use that in our weather app. So what we have here is a subset of the weather data we're actually going to use in our weather app. I've taken the results from one of the queries here for the city of Calgary, for example, brought it in and extracted all the JSON that we don't need. This is just a playground for us to play in and verify we can decode our incoming weather app data. Here's the JSON, and here's the struct that represents this JSON data. It's made up of 3 parts. We have a structure for weather, one for main, and another property here, name, which represents our city. Weather here is implemented as an array of weather objects. So down here I've created a struct called weather, which contains an ID and a description. And this is basically what's going to capture and represent our weather in the app. This ID, as you'll see later on, is actually going to map to the image that appears that tells us whether it's sunny or cloudy. Then in main, we have another struct representing this bit of JSON here. And inside, there's a property called temp to represent our temperature as a double. And then finally, name here is passed back to us as part of our weather data here in the form of a string. And then we can decode that just like we did before. We can take that string, transform it into data, decode it using the struct we just created. And if we run that, we will indeed see we do get our weather and we're able to successfully parse this incoming JSON data. So this is really good now. We know how to parse JSON. We know how to take a JSON request coming in and convert it into Swift code. In the next section, we're going to go take a look and see how to do an HTTP GET request to actually query and get this data and bring it into our application. Let's jump to the next section and see how we can do HTTP requests.